So I will talk a little bit about my research in the PhD, and I'm still working on that. I'm still working on some paper of that. So if you are interested, like we can discuss together later. So what I'm solving here is the communication gap between the facility management team and asset management team. Because in my opinion, that we did some project in China, and we find the very large scale shopping mall, for example, the infrastructure, the high level people, like the senior people that doesn't know what happens at the front. I mean, at the front work. So I use the knowledge graph to bridge the information gap between the two domains, which is facility management and asset management. And that is kind of like follow this structure, which is from the data to information to knowledge and to wisdom. I will not go into detail because I think Professor Brilakis has talked a lot. So all of my research is about how to make the technology used by people. It's a very practical question that Professor just mentioned. So and along the road, we solve many technical issues. So in my opinion, digital twin, we have a lot of data inside, but I want to like decompose it into two dimensions. Like the first is the maturity of digital twin, and the second is the scope of digital twin. So as you just mentioned, a digital twin is a model, right? I think you can treat it as a model. That is because what you want from this model. So it can also be the decision-making tools, and it can also be the visualization tools. So that is related to the maturity of the digital twin, in my opinion. So we can start from the geometric modeling because it's digital, right? We don't have it. And we have the physical one, if we have the physical one in the facility management, for example. And we need to make it to digital. And the first thing we need to do is to do the geometric modeling. And then we need to do the semantic modeling, which is we put what it is inside this building, inside this digital asset. And then we talk about the value, which is what you use for this information. Like you just said, the prediction. So if you want to do the prediction, what is the information inside and to enable you to do the prediction? And then is the scope of digital twin. That's for the digital asset, we can have from the component to the system. So this is my answer. I'm not sure if I've answered your question or part of it. Is that what is digital twin? I think it depends on the client, right? It depends on what you wanted from the asset. Because I was a architecture design student. The first thing we start a project is to have the brief, like Professor just said. And the next thing is what we do in this building and what we do to benefit the context. Yeah. I think I'm not gonna go into very detail of my project because what I did, oh yeah. So here I put into two dimensions because I always want my audience to make it clear that which state are of my projects. And yeah, so here is I'm mostly work on for the project in Cambridge. I mostly work on the geometric modeling of this building. And I do the information enrichment about the fair equipment. And also I did the project involved, one pilot involved in the project is construction progress monitoring, construction progress modeling and monitoring, and then the value assessment of it. So this is our project, is a European project, and we have the building level functions and city level functions. So we had the platform for three cities in the in Europe countries for three scenario, which is built environment climate scenarios, urban flooding analysis and resilience, and the urban heat analysis and resilience. And for the building pilots here, I mainly focus on three main projects, which are digital twin construction, digital twin updates, and digital twin enrichment, which is like more detailed, more technical on that. So here's is the progress from the point we make it to mesh. Oh, I think, it's okay. We make it to mesh, and we enrich the semantic, the thermal information and EGNSS data to make it together and visualize through visualization tools. So, and here's more detail. I may skip this and to continuously introduce what it is step by step. Okay, so here's our point cloud data. We have a city point cloud data, and we want to segment it into ground, roofs, building walls, and openings. And we trained our own neural network through our own self-development data set and 2M facade data set. So, and the next step is to build the semantic spatial relationships between the objects. So in this facade case, the very important one is the relationship between the windows and the walls. So yeah, here it is. I self-developed one geometrics information extraction tool, and I directly to change the format exchange the format of TXT, which is not boot format, and to FC. So the step-by-step process is to first process the raw point cloud data and use neural network to segment it, and use ransack to make it to the instance of wall openings and roofs, and then extract the geometric information of it and to define this spatial connections of this. So here is very interesting. It's also related to knowledge graph. So when I work on the digital twin creation job, so I'm wondering that why the computer cannot understand that this is the wall, this is a window, and it just be together, right? How the system think like human. So I think I can put the knowledge in it during the digital twin creation progress. So my idea is to put the roles, the semantic roles of the semantic restrictions in the knowledge graph. So here I create a very simple knowledge graph, and I think the three key restrictions in the digital twin generation part is the dimensional restriction, which is the size of the building component, and the positional attachment, which is the typology information, and then is the functional attribute, the semantic information. Okay. Here's a very quick example of how the thermal information enriched inside. So because we don't need the thermal information in the FC because it is like city level decision. So we just put it in the mesh. Yeah, and that's all to move it. So next is about the firefighting access. We had a very large fire accidents one couple of days before. So it is very important for us for the regarding the fire safety of the building. So you can see that currently a very old way to manage the system is the 2D map. But 3D model are very clear. So, but currently, if we use some camera to capture the fair information in the building, it is very challenging because we don't have that enough data set. So currently, only we have the FairNet developed by UCL. And we can see all the images are collected in UK, and it's not that good for the computer vision training. So we want to explore our own way to update, to enrich the fair asset information into the digital twin. So we have to first create our own data set, and then we train our own computer vision network, and we project it into the location of the beam model, and then through the geometric information, the positional information, and we retrieve that where have what kind of fair equipment. Yeah, something like that. So we do the labeling. It's very tough. For example, like this, we have the fair house reel here, but do you know that if there's really fair house reel inside, so we can't label it as fair house reel. So we label it as hidden fair equipment. And then the next step we will do our research is to match the equipment sign of it and to send a signal like to check that. Okay, so this is a very quick example. And here is our recall and accuracy of our framework of our the computer vision framework. So we have around 4,000 instances, hundreds of images to collect the 15 categories. Yeah. It's already published. It's open. It's open. Yeah, it's fully open. Yeah. Oh, we just opened it last month, I think. Yeah. And here is a very interesting study is to research the number of the instance to the performance of the model. We can still see that something are not very good. For example, this piping system, because it's like very similar to each other, and it is usually small, right? Because it's on the ceilings. So here is the overall methodology for us to do like from the image to the location in the big model directly. So we use the projection and the point cloud to do it. I will not go into detail of this. The paper has already published. So if you're interested, you can have a look. And yeah, and here is the result of it. I simply use this method in one of our projects in Europe, because the case study we did, we used the civil engineering building. So I apply it into the Poland case. Yeah, and it just shows well. Oh, so here is another project. Is a Zhong-based project construction progress monitoring. We have the as designed beam model with time information, and also we have the Zhong images point cloud collect every 1 or 2 months on the construction site. And here is the input of the data that each element has its information about like when it should be started and when it should be ended. And we compare the each scans to the as designed build model through compare the to check the number of points in the object boundary box. So we align these two model and to check. Yeah, this is the whole process. And then we we visualize it in the construction set. However, we find it's a very interesting challenge, and I think it's a very practical challenge, and we are now working on that. Is because the Zhong images are collected every one month. So there are some objects are below it. So June cannot collect it. So it also be labeled as delayed, which is wrong. So we want to continue work on this question, and we developed the visual language model driven to check the occlusion if the delayed object is really delayed or it is occluded or not. And after we confirm that, for example, it is occluded by other elements. So what is the occluding elements? Is occluding elements is a temporary component of the construction set, or it is constructed object. So, and it also mixed with construction logic to do the step-by-step prediction. And so that we can have the accurate and more accurate result of it. We still have one conference paper on that, and we are working on the journal paper. So yeah, so I will not go into detail of these two slides. It's about how I ask the visual language model and how it answer. So it should be okay. We can use the visual language model to help us, very simple way to check, to solve the problem of drone-based construction progress monitoring. This is another example. Okay, it's coming to the end, which is the data quality concern. And it is also related to the trust problem that you just mentioned, how we trust it. So I think this is very important in our industry. And in the context of infrastructure or building operates, I think first thing, if we work on the data quality, we need to explore what is the data model of it, which means that we need to figure out what is the data quality metrics of it. If we're working on the data trust problem, then what is the metrics of data trust? So I think it's the same logic. And then I work on that what kind of data will involved in the infrastructure operation, but I'm not go from the type of data. For example, the function category is through the function of it, but I categorize is from the data collection method of it, because I think every IoT data we have the same way to collect, right? Every manual input data we have the same way, which is people write something about it. So I have 5 categories of it, which are manual input data, sensor data, system logs, business interactive data, and external data. And for each type of data, we have different data quality metrics. And for the organization, different organization has different capacities in evaluate the data quality, in my opinion. So because it could be very expensive. So depends on the capacity of the organization, which one is important, which one is the most important, and then you should start with that one first. So this is the meaning of this hierarchy table. It's just a very simple example of what we thought about the railway operations value assessment. What is the function, or what is the value assessment indicator of it? So you can see we have to normally people have 3 layers to output the value of the railway operations, which are data, function, and value, which means what functions can get from the data and what value can get from the function. But here we add another layer, which is called data quality layer, to calculate the data quality parameters, and to add another layer of it, like can we trust it or not, or your value assessment result is high quality or not. So yeah, so here comes to the end of my presentation, and I hope you enjoy it and feel free to discuss, please. Thank you.